Hi, in this video, we want to take a look at sampling in survey designs. All right, so sampling, we're going to talk about our methods of when we actually are going through and collecting our data. How is it that we choose the individual that we're going to measure and observe, for our statistical data collection? Now, survey design talks about on a bigger scale, what is our game plan for collecting data? And so this will talk about being a little bit more, more nuanced and more broad about how we're going to handle things. So, are we going to handle multiple points of time? Are we going to have, multiple subjects? Will we follow a subject across time? What variables will we be measuring and observing throughout? So sampling is like the individual execution of it, kind of, but and then survey is more the big picture aspect of data collection. All right, so in statistics, sampling refers to the process of selecting a subset of individuals or items from a larger population for analysis. There are different methods of sampling that can be used depending on the research question and the characteristics of the population. And here we're going to just discuss a few of them. So the gold standard, the one that is the largest focus of sampling, is simple random sampling. So every subject in the population has equal likelihood of being in the sample. That is, every single person or item has equal chance of being measured or observed. So simple random sampling is a type of probability sampling in which every individual or item in the population has equal chance of being selected for being in the sample. This is usually done using like a random number generation or a randomization process. Simple random sampling is often used when the population is homogeneous and there is no need to stratify or weight the samples. So let's think about an example. Imagine you want to survey the opinion of voters in a system. You could randomly select a sample of registered voters from the city's list of registered voters, where each registered voter has equal chance of being selected for the survey. Okay, so now let's go ahead and run through an example. When I run through these examples, I'm going to be using R code to simulate real life. All right, so in real life, imagine like all the people in the United States. It's a huge population, right? If I'm going to be doing a study involving Americans, I can't measure every single American. That's not possible. What I'm going to do is take a subsample of the population, and the people I select are going to be my observed sample, and I'll run my data analysis on the measurements I get from them. Okay, so imagine that this is the population of interest. All right, so here just numbers, 10, 20, 30, 40, 50. If I do a simple random sample, I'm going to randomly select some of them to be in my sample. And so here we are randomly selecting a sample from the population. Here we're picking 3. And on this one, we just happen to get 10, 20, 30. All right, we could have easily just have gotten 10, 30, 40, like in any combination. Just by happenstance, we ended up getting the first 3 values. That's happenstance from the random number generation in R. Now, a stratified sample is here we make sure that our sample represents subgroups within our population. So for example, think about that we want to make sure that each gender, I'm going to say binary gender for the moment. So we want to make sure that each of the binary genders are represented in our sample. So then we'll make sure that males and females are both accounted for. We could do this for other variables such as income of low, medium, high. We could do this for race or ethnicity. Other things that we can do. So stratified sampling is a type of probability sampling in which the population is divided into subgroups or strata based off of some characteristics, such as age, gender, or income. A random sample is then selected from each stratum in proportion to its size in the population. Stratified sampling is often used when the population is heterogeneous and there are important differences between the subgroups. All right, so for example, so conceptually, suppose you wanted to estimate the average income of households in a city. You could divide the city's population into different income groups or strata, low, medium, and high, and then randomly select a sample of households from each stratum in proportion to the number of households in each stratum. All right, and so here we have income of low, medium, high, and age, or some other variable that we are interested in. And we're pretending that this is the total population of the city that I want to look at. And then here, I'm randomly selecting a subset of each of these in proportion to the number of, or in proportion to the frequency of each strata. And so what this does is make sure that my sample, as I collect my data, the subgroups proportions in my sample is close to the proportions of the overall population. It's possible when I go through and do, if I was to do random sampling or any other type of sampling, let's say that, we have 50-50 for males and females. By happenstance, I end up going to like football games. I end up going to sports bars. I don't realize I'm making a mistake, but I go through and I start sampling, and I end up getting 80% guys, 20% females. That's not in proportion to the true population proportion. And so what I would want to do is I would want to make sure if it's 50-50, I would want to get about 50% of my sample from males, about 50% of my sample from females. And so stratified sampling, just make sure that we get in proportion to population characteristics. Now, cluster sampling is the idea that I'm going to select an area or subgroup, and I'm going to sample all of them. Okay, so here, what we're doing, think about like remote regions that I want to do sampling. And let's say that I want to do sampling throughout remote areas of the United States. I'm out in Wyoming, and I can't hit all of these remote towns in Wyoming to include in my sample. So what I'm going to do instead, I'm going to randomly pick a town or a county, and I'm going to get as much data from that town or county as I can. And then I'm going to go to another town or county and sample as exhaustively as I can there. Then go to another town or county and sample as exhaustively as I can. And so here, the random selection aspect is on the location of where the person lives, not at the individual level. And so this is cluster sampling. And so we have geographic clusters for our sampling. So cluster sampling is a type of probability sampling in which the population is divided into clusters or groups based on some natural or organizational or geographic feature. A random sample of clusters is selected. So in simple random sampling, we have a random sample of individuals throughout. Here, we're randomly sampling a cluster, area, or group, and then all of the individuals within the selected clusters are included in the sample. Cluster sampling is often used when it's difficult or impractical to obtain a complete list of all the individuals or items in the population. So specifically think about remote geographic areas that I need to do sampling and get measurements for. So imagine you want to estimate the prevalence of a disease in a certain region. You could divide the region into clusters and then randomly sample the clusters, and then you would test all the individuals you could in the selected clusters. All right, so now let's imagine that this is my population. And so this is the population that I have that, here's the variable of interest is age. Here is my geographic regions, A, B, C, and D. And then what I'm going to do, I'm going to go into a region and I'm going to collect data on everybody in the region that I selected. Now, systematic sampling is exactly what it sounds like. It's systematic. So imagine the idea that I want to figure out the average height of college freshmen. And so I can't go to my school and measure every single college freshman, but I could hang out in my dorm, and every 10th person that walks in through a doorway, I walk up and I ask for their height. So this would be systematic because it's every 10th person. A store could do this with every 5th customer that comes in through the door to ask them to fill out a survey. So systematic sampling is a type of probability sampling which the population is ordered in some way, and every individual or item is selected for the sample. For example, if the population is a list of names, every 10th name could be selected from the sample. Systematic sampling is often used when the population is too large to feasibly sample using simple random sampling. Suppose you want to survey the satisfaction of customers at a store. You could number all the customers as they leave the store. So, first one to leave is number 1, second one to leave is number 2, and so on. And then select the end customer for the survey, where n is a fixed number before you start collecting. And so let's pretend that these are the numbers of my population as they come in, and these are, the numbers are streaming in. Maybe their satisfaction level or some other feature. And what I'm going to do, I'm going to walk up to every 3rd individual and collect the data. And so here you would see that every 3rd number is in my sample. Now, a convenience sample is exactly what it sounds like. I'm taking the data that is convenient. Now, here is the little dirty secret of data science. Convenience sampling is by far, overwhelmingly, the most common type of sampling in data science. Period. End of story. Why? Because we grab the data that's available and we run with it. So example of this, most of the time when I'm taking data out of a database and using it for statistical analysis, I'm probably using convenience sampling, more than likely. I use convenience sampling all the time at work. And the reason for that is that, with the database situation, I'm grabbing as exhaustive of a data set that I can get. Now, if I have a big data problem where the exhaustive data set is too large to work with, I can invoke the other sampling types off of my database to reduce the amount of data I have to work with to speed up the process so that I can actually compute the analysis I need to work on. So convenience sampling is a type of non-probability sampling in which individuals or items are selected based on their availability and their accessibility. I mean, it makes sense, right? I'm only going to take data from people that I can get to get data from. This method is often used in pilot or exploratory studies, but it's generally not recommended for making generalizations about the population. All right, so these are good as initial starts. If I'm doing a scientific research, scientific research is very different than business research. Scientific research, we go through the process of making sure that every step of the way, our work is above reproach. And that includes the collection of the data. And so where convenience sampling comes in for scientific research is to give you an idea of how things will play out when you do your true, correct, proper sampling. And so what you do before you actually start running your study and start collecting your data for real, you go out, grab some convenient data of some people or subjects that are easy to get to, and then you get some numbers off of them, you get your observations, and you use that to give you an idea of how things will go out and what the distributions are going to be when you do your proper study to make sure that you're not wasting your time when you start working really hard on the data collection. So imagine you want to study the behavior of college students. You select the students who happen to be at present in a particular location, such as a student center or cafeteria, at a particular time. However, this method is generally not recommended for making generalizations about the population, and it may not be representative of the broader population. So this is actually true of all types of sampling, that it may not be representative of the broader population. Just that with the other types of sampling, we have taken efforts to try to make sure that our sample is representative of the population. Now, convenience sampling, we don't worry about that. We just grab data as quick as we can. All right, so here, this is my population data set. So pretend that this is the entire population that I have, my entire population that I'm interested in is represented by this data frame. Now what I'm going to do, I'm just going to grab the subjects that are easy for me to get to, easy for me to measure, easy for me to data collect, and I'm going to run with it. So for this situation, we're just kind of saying, hey, it's easy for me to get to the older population that are female, and that would be how we would do that. So here's the conclusion on the sampling. There are several types of sampling methods can be used in statistical analysis. The choice of sampling methods depends on the research question and the characteristics of the population. Probability sampling methods, such as simple random sampling, stratified sampling, cluster sampling, and systematic sampling, are generally preferred because they allow for statistical inference, while non-probability sampling methods, such as convenience sampling, are generally less reliable. Now let's talk about survey designs. And so here we're going to talk about collecting our data in a more broad and general sense. So survey research is a popular method for collecting data in various fields, including social sciences, marketing, and public health. There are different survey designs that can be used depending on the research question, the target population, and the data collection method. We will discuss some of the major types of survey designs. First one we're going to talk about is cross-sectional survey design. All right, so here, this is single point in time. I'm going to run out. I'm going to do my sampling in the manner that we just talked about, but there's only one point in time. I get my data, and then we then we start working with our data. Cross-sectional survey design is a type of survey research in which data is collected from a sample of individuals or items at a single point in time. This design is often used to estimate the prevalence of a certain condition or behavior in the population and to examine the association between variables at that singular point in time. Imagine you want to estimate the prevalence of smoking among adults in the country. You could select a representative sample of adults from the country and ask them whether they currently smoke or not. Now, in this phase, when we select a representative sample, we would be using the sampling techniques that we talked about earlier in the video. All right, so here, let's say that this is the population data set that I'm interested in, the empty cars data set. And what I'm going to do, so pretend that this represents all cars that are in the United States, and I want to go out and sample all the models of cars in the country. Well, I can go through and I can randomly select. So here I'm doing simple random sampling for this one, but we could have done like stratified or some other method. We could have done by make. We could have done a stratified sampling. And so here, this would be my actual sample that I would run statistics on. Now, a longitudinal study is where we have multiple points of time. And in this presentation, we're going to say it may or may not be the same subjects. Now, different textbooks are going to nuance things a little bit differently. Don't get bent out of shape if someone says something a little bit different for the definitions. Just anytime you're reading a paper or someone's talking about it, just make sure they specify the details of this. So here we say multiple points of time, and subjects may or may not appear at multiple points of time. They may be in there once, they may be there twice, they may be there at all sampling times present. We're just saying there is multiple points in time that we are collecting data. So longitudinal survey design is a type of survey research in which data is collected from a sample of individuals or items at multiple points in time. This design is often used as an example of the changes in variables over time and to test hypotheses about causal relationships between variables. Okay, so suppose you want to study the changes in mental health symptoms over time among patients with a certain medical condition. You could recruit a sample of patients and collect data on their mental health symptoms at multiple points of time, such as a baseline, 6 months, and a 12-month follow-up. This would be longitudinal. Now, how this may or may not be the same subjects in that you may not have people who go, so when I say baseline, that could be in January, then in July, that's your 6 months, and then 12 months is December. And so when I talk about this aspect, and for this definition of longitudinal, is that at the beginning, I go and I find patients and I, get my measurements. 6 months later, I go out, find patients, and collect data. 12 months, 6 months later after that, 12 months into the survey, I go and find patients and collect data. And so the patients may appear at multiple points in time or just once. And so here are all of our patients and the time of their current value. So this is the outcome. We actually don't know in the true population. This is what I would observe if I observe this individual at that point of time. And we see that we have all these individuals at the different points of time in the population. Now, when I do my study, what I'm going to do, I'm just going to go and I'm going to collect data at each point in time, and I may or may not have a repeat on the individuals in my survey. And so here is my data collection like that. And so you'll notice that 3 is in multiple times, but 1 is only in there one time on the last data collection. Now, that is one type of longitudinal study where we don't worry about having the same subjects over and over and over. The next one we want to talk about are panel surveys design. So this is longitudinal study, multiple points in time, but here we make sure we have the same subjects every single time. So if they're in the 3rd data collection, they had to have been in the 1st and the 2nd also. So panel survey design is a type of longitudinal survey research in which the same sample of individuals or items is followed over time. So this is important. It's followed over time. This design is often used to study the stability and change in variables at the individual level and to test hypotheses about causal relationships between variables. So imagine you want to study the changes in political attitudes and behaviors over time among a sample of voters. You could recruit a sample of voters and follow them over multiple election cycles, collecting data on their political attitudes and behavior at each election. So here, let's say that this is my true population that I would like to know about. This is the individual, is their ID, and this is at each point in time. And here's what I would observe if I went in and surveyed, measured, observed the individual at that point of time. Now, remember, when we talk about this, the population is too large, too complicated for us to get at, so I'm only going to take a sample to observe. So what I'm going to do, I'm going to select a few people, and I'm going to follow them doggedly on all the time points of collecting data. And so you'll notice that, so here, individual 3 was selected, and they're in there 3 times. Individual 4 was selected, and they're in there 3 times. Individual 6 is in there, and they're in there 3 times. Individual 10, once again, that person was selected, and they're in there all 3 times. Now, cross-lag panel survey designs. Okay, so here we're going to have multiple variables, multiple points of time, same subjects. Okay, so for this one, what we're going to do, we're going to follow individuals over time, just like we did in the previous. So same individuals, every point in time, and we're going to take multiple measurements with these individuals, and then we're going to study the relationship between these variables and different points of time. So cross-lag panel survey design is a type of panel survey research in which the variables of interest are measured at 2 or more points of time, and the causal relationship between variables are tested by examining the cross-lagged associations. So we could be mixing up time series with this, in fact. This design is often used to study the direction and magnitude of causal effects between variables over time. Suppose you want to test the causal relationship between physical activity and mental health over time. You could recruit a sample of individuals and measure their physical activity and mental health at 2 or more points of time, and then examine the cross-lagged associations between these variables to test the causal direction. All right, so that's a lot. Basically, I'm going to get a bunch of people. At time 1, I measure some mental aspect. I measure a physical aspect. At time 2, I measure the same people, mental aspect, physical aspect. So now let's go ahead and take a look at this. So for each individual, I measure them 2 times at 2 different time points. So 2 observations at time 1, 2 observations at time 2. 2 observations at time 1, 2 observations at time 2. 2 observations at time 1, 2 observations at time 2, and so on. Now here I generated a lot of data because I'm going to give you an example of how we could actually run the statistics on this with latent variable analysis. So here before I can actually do my modeling, I need to reshape my data. I need to set it up so that we can figure out what's going on. So here, what's going to happen is that I'm not going to be able to get measurements from every single individual possible. You know, population is too big, it's too complicated. So I'm going to take a subsample of the data, and then I'm going to measure them, you know, physical and mental at 2 points of time. Now, here is my sample. Here are the individuals that were selected in my sample. And you'll notice I've got physical activity 1, physical activity 2, mental health 1, mental health 2. And then what I'm going to do, now that I have it in the right format for statistical analysis, I can run latent variable analysis. That's what the Levon package stands for, latent variable analysis. And here we have structural equation modeling. Here I'm wondering, physical activity 2 depends on mental health during the first recording, and mental health 2 depends on physical activity 1, and then we can, you know, build our model. And this didn't actually print out for me, but that's okay. This is not a psychometrics class. I need to load the Levon package to run the summary correctly. That's all right. Now, mixed mode survey design is where we have a mixture of types of data collection. So mixed mode survey design is a type of survey research in which data is collected using multiple modes, such as telephone, mail, internet, face-to-face interview. This design is often used to improve response rates, reduce non-response bias, and accommodate the preferences of different types of respondents. Imagine you want to survey the opinions of residents in a city on a controversial topic. You can use a mixed mode survey design where you collect data using both online and telephone surveys to reach a wider and more diverse sample of residents. A good example of this in the Orlando area, if you go to Universal, as you're walking out, someone with a clipboard is going to ask you to fill out a survey. Now, Universal is also going to email you a survey, and the app is going to ask you to fill out a survey. And so they've got 3 ways that they are surveying people, and it's mixed mode of face-to-face, app, and email. All right, so now let's go ahead and generate a data set. And so here are a bunch of individuals. Here's how, we would be contacting them, and this would be the outcome if I contacted this person with that particular mode. This is my population. It's too big. I am not able to access all of it. So what I'm going to do, I'm going to run, wow, this is a lot bigger than I intended. What I'm going to do, I'm going to go through and I'm going to do my online survey. And here I'm going to collect 50 observations with the online method. I'm going to collect 50 observations with the telephone method. And what I'm going to do, I'm going to take those and put them together, and that will be my total survey data. So in conclusion, there are several types of survey designs that can be used in survey research. The choice of survey designs depends on the research questions, the target population, and the data collection method. Cross-sectional, longitudinal, panel, cross-lag panel, and mixed mode survey designs are some of the major types of survey designs that researchers can choose from depending on their research needs. All right, well, that's all I've got for you. Life is short. Do math.